Hey everybody, this is Mr. Piercy, and this is going to be a recap, a reflections video for the rotations activity that you were doing to determine the rules for rotating a figure uh, counterclockwise in 90-degree increments on a graph. Now, the instructions that you were given say to use a whole bunch of stuff, push pins and whatnot, but really as long as you have a straight edge and maybe some patty paper, then you really should be in pretty good shape. So this first page isn't something that we're actually going to do anything with. So we're starting off with a triangle that we're asked to perform a following rotation on of 90 degrees, and then to figure out what are the coordinates of the new figure, and to particularly identify what the general patterns of that figure are. So again, before I start putting stuff up here, this is something that you should be watching after you have completed your own investigation. This is kind of like I said, a recap, a review. It's meant to clarify, did I do this correctly? And if I didn't, what corrections do I need to make? So here we go. I guess it would help if I had my pointer going. There we go. So taking the original figure after we rotate it 90 degrees, now counterclockwise is a pretty typical way of doing it. In fact, most things here, let me just go ahead and talk about it now since we're looking at it. If my angle of rotation is positive, we always go counterclockwise. And I'm not 100% sure if the way the quadrants were numbered were based on how figures were rotated, meaning counterclockwise being a positive direction, or if it was the other way around, that because the way the grid is numbered, that we have to go counterclockwise to be in order of the graph, 1, 2, 3, 4. But counterclockwise is always going to be a positive rotation. So here, if we go like that, that would be a 90-degree rotation. If I go like that, that would be a negative 90-degree rotation, where the sign, the positive or the negative, all that's really saying is the direction. It's not that the measurement itself is negative. It's indicating a direction that it is rotating. So here, when we look at the slopes of the figures, we see that after I do a rotation of 90 degrees, the slopes of the original figure, we take the opposite reciprocal of them in order to have the slopes of the rotated image. Moving on, here we're going to do a 180-degree rotation. Now this one is probably going to be fairly straightforward as far as how you would actually do the rotation. If you didn't have patty paper, this is probably the easier one to do. But when we rotate an image 180 degrees, the x and y coordinates remain the same, meaning that they don't transpose the coordinates. However, the signs of the coordinates do change. And the slopes, in this case, the slopes will stay the same. It's not quite the same as a reflection, but it does have some similar characteristics for a rotation of 180 degrees. Now finally, 270 degrees counterclockwise would give us coordinates here. And the general pattern that we're looking at for our rotated image, in this case, the x and y coordinates do get transposed again. However, the x coordinate is the one that has the sign change on it. So x and y trade places, and whatever the x coordinate value was, we take its opposite value. And just like with the 90-degree rotation, here we are going to have slopes that would be opposite reciprocals of each other. And last thing that I want to point out here real quick, since we're talking about it, a 270-degree rotation. Oh, let me put my pen back on. So a 270-degree rotation takes something and puts it right about here. So that would be positive 270 degrees. But a rotation of negative 90 degrees would put me at the same spot. So just FYI. Now here, this one is easily the most obvious ones that we should have had. If I rotate something 360 degrees, I wound up back where I started at, meaning that the coordinates of the original figure, the pre-image, and the image are identical. Now, I want to add a little bit of information here, and this isn't something that we'll really be doing in geometry, but it is something that you'll see later on. Okay, so let's say we have this point here, and it rotates 360 degrees. So I started off with A, and now I'm at A prime. Well, it rotated 360 degrees. I went up back where I started at. Well, there's nothing saying that we have to stop there. I could keep going again and say 720 degrees and keep going from there and say another 360 degrees and be at 1080. These are what we would refer to as these are coterminal angles, because there's nothing saying that I can only rotate 360 degrees. We can rotate and rotate and rotate ad nauseum to infinity if we wanted to. And every 360 degree increment means that those numbers would be considered coterminal angles. So if I was here at 90 degrees and then I rotated another 360 degrees, that would be considered a coterminal angle. If I rotated another 360 degrees, that would be a coterminal angle, because I wind up in the same spot as where I started at, just I've taken more rotations to get there. So here we're kind of taking a look at, how would we actually do it? If I just said I have a figure and I'm doing these rotations, what would we see? Well, these are the general patterns that we established in our tables from the previous figures that you rotated. For a 90-degree rotation, X and Y are transposed, and the value of the Y coordinate changes for whatever it was. The sign changes. X and Y for 180 degrees stay the same, but the values, we take the opposite values of it. And 270 degrees, also the X and Y values transpose, meaning that the X and Y trade places, but the sign of the X coordinate changes. And 360 degrees, everything stays the same. So with the slopes, with a 90 and 270 degree rotation, the slopes are opposite reciprocals, meaning they would be perpendicular to the pre-image. And for 180 and 360, the slopes would not change, they would stay the same. So now let's go ahead and take a look here. We're looking at a rectangle where we're doing a 90-degree rotation. Again, let's check our work here. As long as if you take the rules and you started using the rules, well, if we're doing a 90-degree rotation, you don't actually have to do the actual transformation on the graph. You may want to see the graph, the points on the graph, just so you can kind of get the slopes, and then use the rule for the opposite reciprocals to get the rotated image slopes. But you don't really have to actually perform the transformation at this point once you have the rules established. So here, if we do a 180-degree rotation, these would be the new coordinates and the new slopes. And if I go too fast, just pause the video and check your answers as we go. But this is just kind of a, like I said, a recap video. 360-degree rotation, nothing should stay the same. That's the easiest one to do, and probably the one that I will never ask a question about, simply because it really doesn't change anything. And that is it. So for a rotation, please keep in mind the different ways that the X and Y coordinates change and how the slopes change. Now, out of the types of transformations that we're studying, rotations and reflections are going to be the two that generate the most rules. We have rules for how the X and Y coordinates change, and we have rules for how the slopes change, and those are going to be the most difficult to actually remember. So it's very important that before you take a quiz, before you take a test, that you review those rules and have them straight in your own mind, because they're very easy to mix up. Generally speaking, there will not be time enough for you to recreate all of the investigations that you're doing to see what the rules would be. If I asked you a question on a quiz or a test, to say, well, if I do this reflection and then I do this, well, you have to understand the rules, because if you have to take the time to recreate everything to see what would the new coordinates be, doing the actual transformation on a piece of graph paper or something, you may not have enough time to complete everything. So please keep those rules straight for the reflections and the rotations, because they are easy to confuse. But that's going to take care of this recap video. If you have any questions about anything you've seen, by all means, let me know what they are. Email me, leave me a comment in the Google Classroom, and I'll be happy to help you with whatever you have. Until next time, ladies and gentlemen, thanks for watching and take care.